have any other comments or things that you would like to add, also put those in the Q&A section. That way we have all of our information in one spot. And with that, I'm going to turn it over to Derek.
All right, thanks, Jay. We'll go ahead and I think, Nick, you're going to take over.
Yes, thanks, Derek. Good morning, everybody, and thank you for joining us for this very informative webinar. I'm Nick Ackerson. I'm the Director of North American Sales with Laser Technology. And what we're going to be talking about today is the topic of laser mapping with Esri Collector for utility pole space management, as Jay said. So to introduce our very well-established and experienced panelists, to begin with, Mr. Matt Alexander of Anatum GeoMobile Solutions is joining us today. He is based in Oregon, and he has nearly 20 years of experience conducting field surveys all over the United States for engineering projects. With experience using GPS equipment from the early days, in 2010, he realized that using GPS and laser equipment with mobile phones and tablets was the future, and yes, it is here. And since 2012, Matt has been assisting field users to transition from traditional handheld GPS equipment to more modern mobile GPS that is more productive and more efficient in the field. Then we have Mr. Derek Rash, a 2-decade veteran with laser technology. He is the Professional Measurement Senior Product Manager, and he specializes in all aspects of laser measurement and application in the field. Then we have Mr. Joe Krohn, another 2-decade veteran with LTI as the West Coast Regional Sales Manager that possesses a vast amount of experience in the GIS market and many other measurement verticals. And finally, you have myself, Nick Ackerson. Again, I'm the Director of North American Sales for LTI. Going on about 10 years with the company, supporting the multidiscipline measurement tools that we have. And I want to once again welcome you to our webinar this morning. So for today, a snapshot of what we're going to be talking about follows here. We will quickly cover an introduction on the 2 companies participating today and then dive into the wired and small cell assets. We will then cover the laser technology lineup of measurement tools and what the different measurement routines of the instruments are capable of performing. Then Mr. Alexander is going to take us through his expertise in the field and some of the successes he has been seeing using electronic data collection methods, both with GPS and GNSS receivers, as well as the laser measurement tools. Finally, we're going to wrap up with the Esri Collector laser mapping workflow, a summary, and then some Q&A. Right, so a little bit about laser technology. We've been pioneering the laser measurement market for over 30 years now. We have done so by providing superior service and support. We hold a rich patent portfolio with over 90 patents in laser measurement systems and operating in a worldwide market with an extensive dealer network that has allowed us to serve international measurement needs in nearly 100 countries. And our ISO statement is providing quality through innovation and dedication. And now I want to turn it over to Mr. Alexander. And again, thank you for joining.
Thanks, Nick. Can you guys hear me?
Yes, sir.
Hello?
Yeah.
Can you guys hear me?
Yeah, yes.
Okay, great, thanks. So yeah, so AntonG GeoMobile Solutions here. We are mapping experts, and most of us here have been using GPS equipment since the late 90s. We all come from a field background, so we like to think of ourselves as problem solvers when it comes to mapping problems in the field. We like to provide solutions, and salesmen secondly. So our client base is throughout the U.S. There, you can see on our map there, that's pulled from an Esri map. And we're headquartered in Portland, Oregon, and we have an office in Chicago, and later this fall we'll be opening an office in New Jersey.
Yeah, thanks, Matt. So we're going to just go ahead and get into the webinar, the content, and we were talking about space management on utility poles, or joint use is another way to look at it. And so why is this important? You've got a lot of different companies that want to attach assets to wooden utility poles. And with doing that, there's certain guidelines that these these companies need to follow. You've got separation guidelines of where certain assets can be. So you need to know those distances between there. So we're going to talk about different measurement techniques and know what's on that pole, and also how our lasers integrate with different apps and how you can collect some of this data all for documentation. So we're going to be talking about, again, these measurement routines and what is actually on a pole. So here's just a few diagrams of what is actually measured. You see there's a lot that needs to be measured. The diagram to the left, you've got to take measurements to maybe just the guy wire or the length of the guy wire. You've got that measurement, or measurements up to the transformer. You got separation measurements throughout the whole utility pole, or spans even. And you can see other areas here of different where you need to do that. So in each one of that communication space or that supply space, they need to know those distances between the two, all these different assets. A traditional way right now is using a height stick, but you need to walk up to each one of those poles and go to each one of these assets. So we're going to talk about how you can use lasers being in a safe location and be very accurate to getting these different measurements. So we're going to go through what a laser is, what are these values, and also Joe Krohn is going to talk about different routines and how you're able to capture all those different values. So breaking it down, laser 101. What is in the laser rangefinder? Well, first there's the laser sensor. That measures distances to all different types of objects. We focus on pulse technology, or reflectorless technology is another way to look at it. So there's no need to have another person or a reflector out there to get a measurement to all these different types of objects. Then also we incorporate a tilt sensor. That tilt sensor, what we do is now we're able to get vertical angles. So you can get from 0 degrees to plus or minus 90 degrees with a tilt sensor built in all of our units. Some of the other units we have, we incorporate a compass sensor. So with a compass sensor, it works off magnetic north, and so we're measuring the azimuth, degree of azimuth, or direction even. You can look at it that way. And then we have a modular system called a true angle, where we use an angle sensor. It does not work off magnetic north, so you need to set it at 0. And from there, you're able to calculate the horizontal angles. This is good where maybe there might be some magnetic interferences for the compass sensor, so you can incorporate a true angle that I'll talk about here shortly. So what does that look like with all these different sensors measuring? With our 2D lasers, our True Pulse 200 models, you can see here what the laser measures slope distance, or another way to look at it, line of sight. Then also we measure at the same time inclination. So with the press of a fire button, we're able to get these measurements. We get the slope distance and inclination. And with those two measurements, the instrument automatically calculates that horizontal distance, or HD, and the vertical distance, VD. That's all done with one press of the fire button. With that, also, we have Bluetooth incorporated in these lasers. So as soon as we capture the measurement values, we actually can send out a serial string to a GIS app, and you can capture that information. When we incorporate the compass sensor, the AZ value, or degree of azimuth, now you can see over the right diagram, now we can get those back to 3D values. So again, press the fire button, you get all those measurement values and the calculated values all at one time. And you can see those values all through the heads of the display of the True Pulse models. The 2D, the True Pulse 200 series, you've got here, you can see the different models, a True Pulse 200 and a 200X. You can see also the range accuracy. On the True Pulse 200, we get down to 8 inches in accuracy on the range. And that's overall the whole range, over 3,000 feet. We have Bluetooth incorporated, like I mentioned. The True Pulse 200 can integrate with Android and Windows devices. Where 200X, you can see the range accuracy here is 1.5 inches. It's our most accurate pulse laser rangefinder we have. And overall, that range and the inclination accuracy, you can see is 1/10 of a degree. This unit does integrate with iOS devices. So we'll be talking about that, how the True Pulse integrates with the different devices here later in the presentation. Our True Pulse 360 models is where we incorporate the compass. So now we get our azimuth value. Now these two models you can see are very similar in all the different accuracies. One thing to note is the azimuth accuracy of these units is a half a degree. And there's no pitch or roll limitations with these. So other where you incorporate a compass into some type of these devices, sometimes you can't rotate the device or tilt it too far because the compass may become inaccurate. With our lasers here, there's no pitch or roll limitations. So it's a true vector technology that we've incorporated. The main difference between these two models is the TruePulse 360R is a ruggedized, it's a horizontal configuration, you can see, like binocular style, and it's in a ruggedized waterproof housing. And also these two devices do have Bluetooth, they integrate with Android and Windows devices. The newest model that we've introduced is a TruePoint 200H. We've been shipping this product over the last half year. This is where we've got that pulse technology that I talked about, reflectorless technology, but we've also incorporated a phase module or phase technology, like a laser distance meter where you see the laser pointer. You see the two different accuracies here. With the phase technology, we're down to plus or minus 2 millimeters, and that's great for the different the space management. If you need to know the height differences between two assets on a utility pole, you're not measuring more than 100 feet away from these utility poles, and so this is a great way to get those very accurate distances between these two different assets on there. This model has Bluetooth incorporated, Bluetooth Smart. What I mean by that, it's got BLE, so we can interface with iOS devices, and also we got our classic mode, so still able to talk with Android, Windows Mobile, Windows devices also. I mentioned about the true angle where it does not work off magnetic north, but you can still get that horizontal angle. We have a 200X mounted to the true angle here. And so you can see the accuracies, the angle accuracies when you mount it on a staff or a tripod. So if you're in a magnetic area where the compass might be interfered with magnetic interferences, this is a great device here. And again, we've got the Bluetooth so we can talk with iOS, Android, and Windows devices. So with all these different ways of measuring, there's all different onboard routines that Joe's going to talk about and a way to calculate different values. So I'm going to let Joe talk about how instruments are used in the field.
Thank you, Derek. Appreciate that. Hello, everybody. My name is Joe Krohn again. I'm the sales manager for laser technology for the Western United States. And I've been around LTI, laser tech, since about 1993. And I get to work in some of the prettiest country in the world. From Alaska to Mexico, Minnesota to Hawaii, and all that stuff in between. I've put my boots on the Rockies, and even some back east, Great Smoky Mountains, the Brooks Range, and so on and so forth, but worked in some rugged territory using these lasers. And I've done a lot of utility work in the last decade, especially in the joint pole sector. So I want to talk a little bit about the lasers and how we can grab height values, and there's several different ways you can do this. The first way we'll talk about is the height routine. In the height routine, it's a routine in the laser that uses 3 button presses. The first button press is a distance at a target. Now this is a slope corrected shot. You don't got to worry about being, perfectly horizontal to the pole. You could do anywhere on the pole you can see. It's a nice vertical target, so that's fine. And it's a slope corrected measurement, so we'll get that HD value for you. The next 2 button presses are nothing more than activating the inclinometer. So the nice thing about the height routine is you don't have to have a clear line of sight. So for example, if you need pole height and you got a bunch of brush or grass growing at the bottom of the pole, you don't got to worry about it. As long as you got to see where that pole meets the ground, you'll be able to get an accurate inclination value to it. So it's angle 1, then angle 2. And then that will create that vertical distance segment, or the height. Very simple, very efficient, pretty doggone quick. Now, one nice thing about the lasers is you can hit that back arrow on any of the true pulse lasers and shoot that second angle again. And what this allows you to do is you can work your way right up the pole. After you get a pole height, you can work, or attachment height, doesn't matter if you need the pole height or not, and work your way right up the pole and get all the different heights of those assets, everything you need. And you don't have to start a new measurement routine. There's nothing wrong with starting a new measurement routine at all, if that's what you want to do. This way makes it just a little bit more efficient and quicker in the field, which of course translate to maybe some more dough in the bank. The second way we can get a height is the missing line routine. Now, keep in mind, we have several different models. The TruePulse 200 line is a 2D missing line mode, and the 360s have a 3D missing line mode. In the missing line mode, you're activating all the sensors, so the laser and the inclinometer on each shot. So it's shot 1, shot 2. And then in the TruePulse series of lasers, the default value is the horizontal distance, which of course, if it's a perfectly vertical target, would be 0. You just want to hit the top button one time to toggle to vertical distance value, and that is your height. That is your height segment. Now, with that, you can do the same thing as in height mode. You can hit the back arrow one time and redo shot 2, so you can work yourself right up the pole quite quickly and accurately. Now, keep in mind, if you're going to do a pole height with the missing line, you need a clear line of sight both top and bottom because you're activating the laser, right? So if you have brush or grass at the bottom of the pole, either use the height mode or go clear it out so you can have an accurate shot to the base of the pole. Now, another thing we need to do in this work is span values. You need the distance between attachments, and you can do that 2D. And in that 2D span routine, you want to occupy the pole, one of the poles, and shoot to the next. Pretty simple, but you have to occupy one of the targets because it's only 2D. Now, the 3D value, which is really nice for the TruePulse 360, I'll tell you, this makes it really efficient. Now, keep in mind, you want to calibrate that compass. You're going to learn how to do that. It's not that big a deal. It takes about 30 to 45 seconds. And because you're using all the sensors, including with the 360 model, you're including that compass. So it's shot 1 to one attachment, shot 2 to the other, okay? And you simply look at that horizontal distance value. That'd be your span, or you can use the slope distance value depending on what you're trying to do, what you need to calculate between those two attachments. So one thing you need to find out is if you're looking to do new construction or working for a customer that is going to be hanging fiber optics, for example, you'd want to use that slope distance value so you make sure you're not short on the material. So you got to kind of keep that in mind. Super simple, super easy, super efficient, and it works very, very well. Then, of course, we have clearance values. So you got clearance between the low part of the sag and, let's say, vegetation on the ground or a roadway or some other right-of-way like a railroad. There's several different ways you can get this done. One of the easiest ways, I think, is the missing line value. So it'd be shot 1 to the lowest part of the sag, shot 2 to, for in this example, to the road. And keep in mind, you want to be perpendicular to shot 1. So you want to be perfectly positioned shot 2 underneath where you shot the conductor. And you could do that in the TruePulse series of lasers. When you do shot 2 and missing line, the continuous mode turns on automatically. And all you have to do is pan around until you get the same horizontal distance in shot 1 as you do in shot 2. And that way you know you're perpendicular. And that includes vertically and horizontally, like if you're doing danger tree or veg manager or side limit or something like that in a utility type application. You might want to get the clearance between the low part of the sag and the ground. This works quite well for that also. Now, the sag routine, in some contracts, you might find you need to know the elevation changes between attachments in the span. And again, that's the missing line value, right? So it's just shot 1 to an attachment, shot 2 to the second, to the middle low part of the sag, and you'd want to toggle that top button down on a 360 model one time and look at that vertical distance value, which would be the elevation change between shot 1 and shot 2. Now, in this particular scenario, this is nothing more than a two-dimensional solution. So even with the True Pulse 200, you could be at any angle you want because you're looking at that vertical distance value, and that's perfectly accurate. That's just a 2D solution. So the math is very simple, and it's you could do it in any angle from any position with a True Pulse 200 line.
Well, hey, yeah, thanks a lot, Joe. So there's a routines that Joe talked about, all these different values that need to be measured. And the one thing it is, our True Pulse line does not store any of these measurement values. So that's one thing we're going to talk about is you want to collect the data for documentation purposes. So what we've done is we've got a couple apps that we've created. One is called Measure, and it works on Android and iOS. And so we can capture all those values that Joe talked about. It's a free app that you can download and test with our lasers, seeing how it interfaces with different devices. So we can get those different measurements. As you can see here over to the right, one of the screenshots, we show that horizontal distance value, all the different values of what the laser's given you. So we can, again, like I talked about, once you press the fire button, the sensors measure, and you can see those different values populate in this app here. You can also take a quick picture and make some notes. Not just distances, but we can do the heights or the missing line routines that Joe talked about, 2D and 3D, and you get all those values right there. It's kind of a quick, easy app to capture some documentation so you can go back and look at it. But it's not more of a full GIS app that some of you might be familiar with. So those type of workflows, that GIS workflow of collecting data, is typically using a GPS or a GNSS device where you need to walk up to that feature. You walk up to the feature, make sure you got a clear line of sight, and you start collecting your data, GPS data. From there, you go ahead, type in your notes that you need to at that time, verify everything's reliable, and you capture everything you need to, and then you're going to need to walk to that next feature and repeat these steps. Now, what happens is there's a lot of different environmental conditions that come into play that could affect capturing data that way. Right here, we're just listing off a few. Say if you need to capture multiple features in small or even large areas. So you're going to walk to each one of those features. That's going to be time consuming. We all know collecting data, you want to make sure you're collecting accurate data, but also not taking too much time in the field. Or might not be able to access the property. I think right now, everybody is a little worried about people walking up and down streets. So if you need to measure to a utility pole, you need a map or get that location of the utility pole, how are you going to do that in private property? So that's another, we're going to show you different ways to do that. Now, lasers don't work in every condition. So there's fog and rain and snow that do affect the laser. I mean, we can't get measurements through all that at times. We do have some different routines and different measurement modifiers, what we call them, to get through some of that stuff. Also like vegetation and everything like that, but they can't always work in every condition. So you can see here a lot of different ways that routine, that normal GIS mapping routine of using GPS only can be affected. So when you incorporate a laser into your workflow here, this is what we're going to do is Geo Reference Routine, or what we call a GPS laser offset. So you're going to occupy a safe location, not on the highway or on somebody's property, and you get your GPS coordinate. With the GIS software or app that you might have that has a laser interface, what I'm going to do is go ahead and fire the laser and get all that information. I'm going to get the distance information, that vertical angle, and also the azimuth. And with those values and the GIS software, it calculates a remote GPS coordinate. So I can stand again in one location and take a measurement with the laser and get all that information, and it calculates that GPS remote coordinate. And so I can do multiple features from one place. So I don't have to close down highways or anything like that. I can stand in one location and get all these measurements. And that's kind of what Matt's going to talk about, is more of our laser mapping workflow with different apps and how he's using it in the field.
Thanks, Derek. So what we're going to be discussing here for the latter part of the presentation is how to automate the workflow he's discussing with, in particular, Esri's ecosystem. And Esri, as far as GIS software is concerned, they're kind of the bigger company in the U.S. and the world, really. So what Esri was able to do by working closely with laser technology and working closely with EOS Positioning Systems, who makes the Aero brand of receivers, was to be able to get all three companies' hardware and software to integrate together. And integrating all those three parts together was able to, the first time, create a mobile solution with laser offset. So laser offsets with GPS has been around for a while, but up until this particular integration, it was only available on old school, Windows Mobile handhelds, and that's just, being eclipsed by the adoption of mobile devices. So what this integration between these three companies allows us to do is it allows us to maintain centimeter accuracy when we're collecting data in difficult areas for GPS. And when I say that, what I mean is that GPS technology is based on frequency that's sent down from navigational satellites, and it's received by the GPS receiver's antenna, and then it's calculated to figure out our position. But the problem is those signals are traveling so far from the navigational satellites that they're too weak to go through physical objects like, say, radio waves or cellular waves. So what happens is we call a difficult environment for GPS something where, let's say, we're up against a building at, say, a gas meter, and we're trying to record that position. The problem is the building's blocking half the sky above us, and it's reducing the number of satellites, so our GPS accuracy is greatly reduced. And the same thing happens when we go up under a tree. The tree canopy, the branches, the leaves, they're blocking the satellite signal, and that's making it more difficult for the GPS to get us an accurate position. But we can replace that solution by integrating this whole three-company solution that we're going to talk about now. So the equipment that we're actually going to use is going to be on the software end, running on your phone or your tablet. It's going to be Esri's Collector app, and a lot of folks are probably familiar with that. On the laser technology side of things, we're going to require the TruePulse 200X laser rangefinder pictured here. And then additionally, there is the option to use LTI's electronic angle encoder, the true angle, and we can use that in our workflow too. But basically, all these things combined with an EOS Aero GPS receiver allows us to accurately capture our assets from a safe distance. So in this slide, we'll kind of go through each one of these photos here, but starting with the left, that is an example of difficult environment for GPS equipment. Not only is it underneath tree canopy, but you can see we have, buildings on either side of that sidewalk. So there's very few satellite signals that are going to make it through all that terrain there and between the buildings. And then along with those things, it's going to greatly decrease our GPS accuracy. So we have the laser, and we can stand back outside of that alley in the open, allow our GPS to track the satellites and get its best accuracy, and then use the laser to shoot down the alley to capture the position of the asset we're interested in. So the second slide here, this is a screenshot from the EOS application running on your phone or your tablet. And the nice thing about this is the EOS application is communicating to Esri's Collector mapping app. It's also communicating to the Aero GPS and the LTI laser rangefinder. And what it does is you choose the particular type of data collection that you want to do with the equipment, and then it will walk you through step by step by step. And once you complete all the steps, it'll automatically reopen the Collector app, and it's going to drop the position of the point you just collected accurately where that asset is and not where the user's standing with their GPS. And the third slide there is just a photo of the Aero GPS, the 200X on top of the angle encoder, and that mimics a total station solution. And then it's hard to see, but there's also a tablet kind of at the bottom there that's running the software. In our last image there, that is a screenshot of the Collector app, and you can see that even if you're using the laser and capturing all that information, it's also still able to capture your metadata information. So it's still going to capture your estimated accuracy, and then obviously your latitude, longitude, and elevation information. So as I briefly mentioned, there's 3 specific workflows with slightly different equipment and software. So range, intersect, I usually refer to just as range, is one solution, and that specific solution is really going to use the TruePulse 200X. Range azimuth, we'll go into details on that one, but that one's interesting because we can use the 200X or the 360, and it actually allows the user to use their own mapping software. They're not locked into Collector. Range Backsight is cool because it mimics a total station workflow where you're going to set up one time, and without moving, you're just going to shoot as many points of assets that you need. So we'll just dive into the workflow so we can give the attendees a little better idea of kind of how it works. So range, that is our most common solution for clients. It's the Aero GPS receiver, and we mount on a survey pole like in this photo here. And then at eye level of the user, we're going to mount the 200X TruePulse to the pole also. And then we can mount the tablet or phone to the pole. And that way that gives the user one hand to hold the pole, one hand free to shoot the laser, type into the application, either on a phone or a tablet, and then quickly move down the sidewalk. So it's a very mobile solution, and because of that, it's really popular. It's mobile and it's automated. So the workflow for this would be, let's use this example of a manhole, right? So we don't want to run out in the street and play Frogger. We want to stay safe on the sidewalk. So what we're going to first do is find our manhole we want to record a position for. Let's walk up the sidewalk, say 10 feet, and we're going to record our GPS position. We're going to shoot the laser rangefinder at the manhole. The software is going to save all that information. We're going to walk back down the sidewalk and past it, so we're not perpendicular to it because we need to triangulate this. We're at our second place, we'll record our position with the GPS. We'll shoot the laser rangefinder at the asset again, the manhole. Then the software can calculate the 2 positions and the 2 laser rangefinder shots and can accurately triangulate that position. And then it's just going to drop that right into Esri's Collector app, and we can hit save, and we can keep moving down the sidewalk to our next spot. Range azimuth is kind of a hybrid. It's more manual. So with this solution, you can stay in one spot. However, you have to manually input information. And this is because the TruePulse 360, while it has internal compass that the 200X doesn't, which forces us to do, the range triangulation in the last example, the TruePulse 360 will not communicate to iOS that's running the Collector app. So there's kind of 2 parts to it. One, it allows users to still use Esri's Collector, but it also allows users to use their own mapping app. So if you have a different mapping app than Collector that you like better, you can still use that, because what you're going to do is for your point collection form, you're going to add a field that allows you to manually type in the distance after you shoot the laser from the user to the asset. And then you want a second field where you're going to manually input the compass bearing that the laser rangefinder is also going to show you at the same time that it shows you the distance to the asset. So it's kind of the same number of steps, just a different workflow. But the ability to use your own preferred mapping app is kind of a nice feature of this one. And then range Backsight, like I mentioned, that is the most similar to a total station for folks that are familiar with total stations. it allows you to set up one time and shoot many assets. So the workflow is to set up at that BS point there. And what that's going to do is you're going to record your GPS position, you're going to mark it on the ground, then you're going to move to that CP point there, and you're going to shoot the laser back at the ground where you would record your first position. And that's going to sort of set the angle encoder in place. And then from there, with your Aero GPS, your 200X laser, and your angle encoder, you can then, without moving, collect as many points of features all around you as you want. And a good example of this would be our cemetery and our botanical garden clients, where they want to accurately get the position of the trees on their landscape, but they know if they walk underneath a big tree, they're going to lose position with just a GPS alone. So a lot of these folks can set up this solution here out in the open, spin in a circle slowly, collecting all the trees they can see, then pick up, move over to the next area adjacent to it, and then redo it. So it's really great for those folks. It speeds up their ability to capture accurately the position of many, many trees. So this is just a quick breakdown of the 3 workflows we just discussed. Range Backsight, it's a little more expensive because we're adding the angle encoder, but it also allows the user to stay put longer. Range Azimuth is the least expensive, but there's more manual input since the user has to manually type in the laser distance and the laser bearing. And then the way that Range Azimuth works once you get back to the office is you can post-process those points, because your person, yourself, or your GIS staff is going to look at all the points you collected. They're not where the asset was. They're not where the manhole was. So they're going to open that point. They're going to see that the user said it was, 23.7 meters, and this is the compass bearing. And then they're going to tell the software, move this point, this distance, this bearing. It's going to move it. It's going to drop the point right on the manhole. They're going to save it. So there's more workflow. So it's one of those ones where it's least expensive to deploy the field, equipment-wise, but then it's more user-intensive, so you spend more money on labor. So it's a trade-off. And then lastly, like I said, range is definitely our most expensive, or our most common and used solution, and then it's the middle of the road as far as the equipment pricing. So there's actually a surprising number of environments and jobs and tasks that we can use these various 3 workflows for. So street lights and urban forestry, I kind of mentioned, cemeteries and the botanical gardens. Not just street lights, but the power poles that we were discussing. We have some clients, because they need to map accurately all their power poles, but the power pole line might be, a couple hundred feet off of the road, and there's a barbed wire fence to go over the whole thing. We have one client in the Great Lakes area where they actually are set up with a car, and they just drive, stop, shoot the laser out at the feature, the pole, record its position, and then move on and move on and move on. And then they have a different team that comes along and actually does the measurements for all the different attachments. So that's one solution, just remotely capturing the position of features. We mentioned manholes. Water and gas utilities are sort of an interesting option because of the fact that being up against a building many times, if we walk up to that building, like I mentioned, we'll lose our GPS position. So instead, we can stay out in the open, get highly accurate centimeter grade position with our GPS, shoot the laser at that particular meter, and then save it in Collector at that high accuracy position. We did mention plenty of stuff about trees and buildings. Veg management, this is an interesting solution because of the fact that utilities that have power transmissions, they need to be able to monitor vegetation encroachment on their right-of-ways and cut back trees and vegetation that encroaches too much. So instead of walking the whole pathway, a lot of places, especially in the western U.S., the roads will kind of zigzag back and forth underneath the power transmission line, but there can be large gaps between them. With this solution, every time the road crosses the power transmission line, you could hop out, look up the power transmission line, remotely capture any trees that you can tell are coming over the right-of-way, turn around, do the down transmission line, hop in the car, drive around until the next time it connects, and then do it again, instead of walking the entire length of that transmission line. And then private property, as we mentioned, there's COVID issues, but then there's also pre-pandemic, just regular standard private property issues. One really cool example, I have a water utility client, and in their city, they needed to map all of their, water meters. And newer homes built in the last couple of decades, the water meters are usually out at the street. That's easy. They just drive up, pop the lid, hold the GPS over it, save it, go to the next house. But older homes, especially for this client, a lot of them, the water meter is actually in the front of the house, right on the side of the building. So they would have to go up, knock on the front door. I'm the water company. I'm looking at your meter. Go record the position of the meter and then go to the next house. But the other problem with just having to deal with public is that water meter is getting blocked by the house and maybe even the roof eaves and greatly decreasing GPS position. So what they've been doing for the last 2 years is just standing on the sidewalk, getting to the new house. They record their position with the GPS, shoot it with the laser, save it, walk to the next house.
All right. Well, thanks, Matt. That's a pretty powerful solution and workflow indeed. So to wrap it up, what did we learn today in this webinar? Well, for one, we learned how to get challenging measurements from safer locations utilizing GPS and laser mapping. We learned that by doing so, more productivity and more efficiency is the result from having the right tools for the project. It taught us that you can maintain precision accuracy in the field and not jeopardize the quality and the quantity of the data that is collected. And we also learned that we now live in a day and age of convenience where bringing your own device is the norm. And then finally, some trends that we've been seeing in the market are RTK and GNSS mapping has come full circle with you being able to use your iPhone, iPad, Android device for centimeter grade accuracy data collection. Two, mobile GPS mapping apps are really taking hold because of increased customization across all operating systems for interoperability. And then laser rangefinders are the preferred tool for obtaining hard to get or unsafe measurements to complete your asset collection project, translating to higher accuracy, both indoors and outdoors, and provide a more complete set of data. You don't want to be leaving data in the field. So to conclude, we've got some contact information up here. We've got Matt Alexander's at Anatum GeoMobile Solutions, as well as Laser Technologies information there on the right. So with that, we'd like to conclude today's webinar and open it up for any kind of questions and answers anybody has in the audience.
Hi, Nick. Yeah, I have a few questions that have come through. To start with, there was a question asked, what other software can you use with a laser rangefinder?
There are many you can use out there on the market out there. I think Derek, Joe, and Matt would probably be better prepared to cover all of the softwares, but softwares like Collector and Survey 123. I think there's a Cartopack one. Derek, would you like to elaborate on that a little bit?
Yeah, sure. Just like you mentioned there, Nick, Cartopack does have a laser interface built in. We have our own, mentioned, I just talked about Measure is one, but we also have another one with MapSmart that we've developed that we have a laser interface built in, and also with GPS and performs that laser offset function with that. And Matt, do you carry any other apps that you wanted to talk about that we have laser interface with besides those?
Not specific laser interface, but as I did mention with Range Azimuth, because the entry is manual, you can actually use any particular mapping app that you may prefer. Whether it be something like the WildNote app that a lot of natural resource folks use, or Fulcrum. As long as you enter field, so you can manually input the distance the laser recorded and the compass bearing. When you get back to the office, you can actually post-process that and accurately move your position to the feature you were shooting with the laser.
One that jumps into my mind that lends itself pretty well to the utility type applications is GeoJot. That's an app that runs on several different platforms.
Yeah, thanks a lot, guys.
We do have another question. I know that we talked about RTK impaired environments, but this question is specifically about acquiring points through obstructions and what you would do. Do you move your position to acquire the point, or how would you manage that?
I can talk from one standpoint. I mentioned there's other laser rangefinders. We do have a couple other measurement modifiers, we call them. What I mean by that is we can turn it into, like what we say, farthest mode, where it's going to try to measure through some vegetation to get to the object. So if there's some of the vegetation that can measure through, it's going to try to get something that's behind that. But if it's actually you cannot see that, I mean, if you're looking at something and you cannot see that where you're aiming at, line of sight, that's where you have to reposition yourself. So it's pretty quick, easy, like it's traverse function. I can move over to the next control point, just measure over to it. I'll move the whole system over to that position, and now I can continue on to do that laser offset to capture that remote positions.
And to add to that too, the lasers also come with a filter mode, electronic filter mode. So if it is possible, you can put a reflector on the target and then use the laser in the filter mode, and the only target it'll grab is that reflective target. And I've used that many times out west here, and you can shoot through a lot of obstructions and grab targets with that particular method. And also to keep in mind with the farthest mode, which works great, is you got to keep that fire button pressed down a little bit longer because you might see some measurements update. It's looking for this last thing it hits, so you want to keep that fire button pressed down longer. But that also works great.
Yeah, perfect, Joe.
That is, I've combined most of the questions, so that seems to be the questions that we have for today that have come through.
Well, thanks, Jay. Thanks, everybody. And if you can always reach out to, again, either anybody here, again, reach out to Matt if you have any other questions about the system. I really appreciate everybody's time today about the time to get this. And Jay, you mentioned this recorded, so we're going to share that with everybody also if you want to follow up.
Yes, that's correct. We are recording this webinar today, so we will be sending out the link in about 3 or 4 days. And this webinar should be shared with anyone who was not able to attend the entire time, or to anybody that you think might benefit from this information. So thank you everyone for your time today.
Yes, thanks.
Thank you, everyone.
Thank you.